All right. So what we got to do first in this problem? Come on, let's go. How do we set it up? What's missing? Olivia.
X.
Got to add a 0x, right? Did you remember to do that?
Yeah.
That's good. You remember that part. Okay, so all I worry about is 8x cubed divided by x, which is really easy. What's that answer? 8x squared.
Why is there 0x?
Because if there's an x cubed, there's got to be an x squared, an x, and a constant. You have to put them all in. Because an x will show up as we go through this. You'll see that in a few minutes. So now what do I do with this 8x squared? Multiplied by the x and the 2. Now what do we do? Subtract. Procedure just repeats now all the way through. So you divide the first term by x, get the answer, then multiply that answer by those two and subtract. You just keep doing that until you get to your remainder.
Wait, could you say that again? No, just.
You take the first term divided by x. Whatever the answer is, you multiply by these two and subtract. Just keep doing that. What's 6 minus 16? Negative 10. Bring down the next term. What's negative 10x squared divided by x? Those are easy division problems, right? Now multiply this. Negative 10 times x. Negative 10x times 2. You just need to keep up. Okay? So, what's 0 minus a negative 20? 20. Minus a negative is addition. Bring down to 7. Start over again. What's 20x divided by x? 20. So you put 20 up here, and then you take that answer and multiply it by x and the 2.
Wait, why is it 20 not negative 20?
Because it's positive 20. Minus a negative makes it positive, right? And then 20 times 2 is 40. Subtract. What's 7 minus 40? Negative 33. That's my remainder. Okay? So I put that as minus 33 over x plus 2. There it is. So it's the same procedure, you just keep repeating it. It's not hard division. It's a monomial divided by a monomial each time. When you divide by 1x, that's an easy division problem. All you're doing is subtracting 1 from the what? If I'm dividing by 1x, all I'm doing is subtracting 1 from 1. The exponent, yeah, that's all. You should be able to subtract like terms. All right, number 2. Or was it 4 we started with? 2. It was 2, 4, and then 14, wasn't it? All right, number 2 came out nice. There was no remainder, 5x minus 2. Number 4 was x minus 7. And then your remainder was 38. So you put plus 38 over x plus 5. Number 14 Came out nice. Then you got 3x minus 6, no remainder. 16, you have to add a 0x squared in there. Hopefully you remembered that. You get x cubed plus x squared plus 4x plus 9. And you got a remainder of 22. So you put plus 22 over x minus 4. And then number 18 worked out nice, no remainder. You got 2x plus 1. Let's look at 16 just for another practice. That was the bigger one. So I'm dividing by x minus 4. Work that out here. And it starts out as x to the 4th, so I have to make sure there's an x cubed, an x squared, an x, and a constant. There is an x cubed, but there isn't an x squared, so I have to put the 0x squared, because 1 will show up. Then my minus 7x and my minus 14. Okay? So if you forgot the 0, that might have messed you up a little bit. Again, now all I'm doing is dividing this monomial here, this first term, by the x. So all that is x cubed. Multiply x cubed times x, and x cubed times negative 4. Subtract. Those will cancel. Minus a negative again. So that's negative 3 plus 4, which is a positive 1. Bring down the next term. So 1x cubed divided by 1x is 1x squared, right? X squared times x is x cubed. X squared times negative 4 is a negative 4x squared. Subtract, those cancel. Minus a negative again. So that's 0 plus 4, which is 4. Bring down the minus 7. 4x squared divided by x is 4x. Multiply 4x times x and 4x times negative 4 minus a negative again. So what's negative 7 plus 16? Thank you. And bring down the minus 14. What's 9x divided by x? 9. So 9 times x, 9x. 9 times negative 4 is negative 36. Subtract. So again, minus negative. So negative 14 plus 36. What is that? No, negative 14 plus 36. 22. So that's my remainder. So I put up here plus 22 over x minus 4. Simple. Any questions before I move on to the easy stuff today? All right, synthetic division is the shorthand method of dividing a polynomial by a linear binomial by using only the coefficients. So what we're going to do is write the coefficients. We're not going to worry about writing any of the variables, not till the end. For synthetic division to work, the polynomial must be written in standard form using 0 as a coefficient for any missing terms. All right? Just like we did with the long division. That last problem we did, the x squared was missing, right? We had to add the 0. So we're going to put zeros in here as well. The divisor must be in the form x minus a, which means it's a binomial. Okay? So, here's an example. So we got 2x squared plus 7x plus 9 divided by x plus 2. Okay? So what value of this x here in x plus 2 makes that equal, that binomial equal to 0. -2. So that's why this red number's here. That's -2, because that was x plus 2. If this was x minus 2, this red number would have been a positive 2. So basically it's the opposite. Okay, so I call that the little corner box there. So whatever this binomial is, tells you what number to put there. The 2, 7, and 9 came from the coefficients. I got an x squared, an x, and a 9. I don't have to add any zeros. Okay? Everything showed up. Okay, you make a line, giving yourself some room, because you're going to write some numbers above this line and below. Okay, so in long division, we dropped the last number, the next one in line as we went, right? Well, in this problem, synthetic division, we dropped the first number under the line. And then I multiply. What's -2 times a positive 2? That's where that -4 came from. So you do multiplication to get the number above the line. You do addition instead of subtraction. You do addition to get the number below. So I add those two. That's how the 3 came about. So then you just repeat. What's -2 times 3? -6. That's how that came about. Then I add these. 9 plus a -6 is positive 3. This last number is the remainder. Okay? So when you write your answer, since this started out as x squared, your answer will be x to the first, 1 less. If this was an x cubed, then this number here would be an x squared to start out. It's always 1 less exponent-wise. Same variable, just 1 less. So that's how they got the 2x, because originally that was a 2x squared, so this becomes a 2x. So 2x plus 3, and then write your remainder, just like we did last night with the long division. A lot quicker. Okay, so let's do another one. All right, do I have to add any zeros? No. All right. So since it was x minus a third, we got to put a positive 1/3 in our little box. Okay. I think it's on the next slide. No? Okay, I get to finish it. Good. All right, so I make my line. And then I drop the 3 below the line. That's the first one. Now what do I do with the 1/3 and the 3? Multiply. 1/3 times 3 is 1. That goes above the line. What do I do with the 9 and 1? Add. Right. So what's 1/3 times 10? Right, 3 1/3, right? Or we just go 1 times 10, right? 10/3. And then what do I do with the -2 and the 10/3? I add, which is 4/3. Or 1 and 1/3. Or 1.3 repeating. That's my remainder. So my answer is 3. What did we start out with? The next to the what? What's that say? Squared. So this is 3x, 1 less, x to the first. Plus 10. And then plus, you can write it 4/3, 1 1/3, 1.3, however you want to write it. What were we dividing by?
No,
X minus 1/3, the whole thing. I don't know why they gave us a fraction to start out, but it's doable. Olivia.
Yeah, the other way.
You will be told on the quiz when we get to it to do 1 or 2 by long division, and then the rest can be synthetic. Yeah. But when you're told to do long division, you're going to have to do long division.
Yeah.
All right. So what goes in my corner? Everyone okay with that? Then I need a 3. Then what? -1. 0. Good, Kate. Why? There's no x squared, right? You got to put a 0 in that spot. Then the 5. Then the -1. Drop the 3. -2 times 3. Add. -2 times -7. Add. -2 times 14. Add. -2 times -23. Add. Scott, what's my answer? Trent. Come on, don't get an O for your table. That's the remainder. 3 what?
3 minus 7, 14.
Right. What else? What about the variables? Moser.
No.
Grant.
I don't know.
Sammy.
I got it.
Ian. 3 what?
X.
Wow.
You got some correct.
I said.
That lasted for way too long.
What did I just say here?
He goes down by 1.
It goes down by 1. So this was a 2x squared to start. So when you drop it down, it becomes a 2x, 1 less. This one was a 3x squared to start. So when I write it, it becomes 3x to the first, 1 less. This is a 3x to the fourth. So when I write my answer, it's 3x to the third to start, 1 less. So what's this? Simple.
I don't like this one.
Do this one on your own. Come on. We are not very focused today. Let's pick that up.
I know how to do this.
Don't write the variables when you do this until the very end.
I like pretty better.
You'll get it.
I know exactly how to do it. No, I'm not. No, I'm not. Just, I don't know.
I think I didn't write that.
I don't know, I might be wrong.
I don't actually know.
Well, I think you can drop the 6 right now. I don't see it.
Yeah, it is 6.
What's up, Whiskey?
I have everything done until my exams are done next week. I'm hoping to start to just let me go. I can do it. That means I'd be able to go home after that. I will keep make sure all the 4 classes, including these.
And then,
Sorry.
I don't even know, like, I know what I'm taking next year, but I wish I could take
Why can't you?
because I already have all my other classes found out.
What classes are you using?
Regular English and math. Yeah, regular English and math, both credit design, part 3, personal finance.
I just so.
Oh, it's so easy.
Both graphic design, there's only one graphic design.
Yeah, that's credit design 1 too.
Oh. I didn't know.
Yeah, 1 semester, so it's basically a full year.
Oh. See, when you said 1, 2, I thought you meant 2 separate different graphic design classes.
Well, they technically are like separate, like, graphic design 1 is on first semester, and 2 is second semester right after. But they basically like flow into each other.
Oh.
But you can take them like separate years, but
I think that's fun.
I don't know.
yeah.
I'm taking both my quizzes here.
I'm right, I think, that's awesome, that's probably
I
right.
tried doing graphic design my freshman year, but they told me that they don't allow freshmen to do graphic design. I was like, it's a junior, it's not
Yeah, the
class.
junior and senior class.
So I just kind of waited. Oh, hello.
Joe.
Jimmy.
Oh, you added here.
You're right. Wait, which one are you playing to?
All right, so what goes in my corner? Anybody have an issue with that part? Do I need to add any zeros? No. So it's 6, -5, -6. You take the minus sign as part of it, the sign, or think of it as a negative sign. Make a line. Where's this 6 go? Below, right? Now, I go -3 times 6 to get the number above the line there. Now, what do I do with these two numbers? I add those. So that's a -23. Again, and I repeat the process. -3 times -23 is a positive 69, right? And then add those. What's -6 plus 69? 63. So my answer then, it started out as a 6x squared, so this is a 6x, right?
Yeah.
And then my remainder.
There's another one. Oh, we have a theorem?
Okay. This is called synthetic substitution. You do it the same way. X minus 3, so what do you put here? 3. What's in front of that? 1, -4, 5, and 1, right? Everything's the same. 3 times 1 is 3. -4 plus 3 is -1. 3 times -1 is -3. 5 plus a -3 is 2. 3 times 2 is 6. 1 plus 6 is 7. Okay, everything's the same. But the difference is, because they're calling it synthetic substitution, you don't have to write this out. All you're worried about is what the remainder is. Okay? So if I were to substitute 3 there, here, and here, and did that problem, what would the answer be? 7. So instead of substituting 3 in for x, you substitute it in the little box and do synthetic division, and the remainder is the answer to the problem. Okay? But everything's the same. Okay? Now, it says what x is supposed to be. So what goes in my box? No. When it does it this way, whatever it says x equals, you put in the box. Okay, so it's just the 2. Don't change it to -2. That's the mistake you'll make. So when they tell you, when they say synthetic substitution, they'll tell you what x equals. They'll tell you what to put in the corner. But everything else is the same. I got my 2, I got my 5, I got my -1 and 7. Okay? So, drop the 2. What's 2 times 2? What's this? 2 times 9. What's this? 17. What's 2 times 17? What's this? What's the answer?
41.
This is 41. You don't have to write out the 2x squared plus 9x, okay? Got it? So, what am I going to put in the box? -1/3, right? I got an x to the 4th. I got an x to the 3rd. What's missing?
X squared.
So what goes here?
0.
There you go. Then the x,
-3.
and then the 5. What if there wasn't a 5 here? Then you add a 0 on the end. -1/3 times 6 is -2. -1/3 times -27 is a +9. -1/3 times 9 is a -3. -1/3 times -6 is a +2. Got it?
Yep.
Simple.
Sorry.
I'm gonna hurt
I just seem to be bullying you today.
Just got it for us.
It's not even on purpose this time.
Oh, yes. This is she made this one for me too. We've got some that also, a royal with like the logo. Yeah, looks good.
Oh, never mind.
You like you?